Usually after or the second course on calculus in high school, it's called Calculus BC. So this is integration of inverse trig rules, and before I get started, it's kind of a long one. I'm going to do a review of stuff here, you guys. So let's find the exact values without using a calculator. So the tangent of inverse sine, so this is either arc sine or inverse sine of 3/4. Okay, so what I'm going to do is let y equal this inside stuff right here. So then if y equals that inside stuff, then we're looking for the tangent of y. Okay, and so when I have y equals inverse sine of 3/4, that just means that the sine of this thing over here equals this 3/4 right here. And then set up a generic right triangle right there. There's y. Sine is opposite over hypotenuse. Okay, using a little bit of Pythagorean theorem right there. I get that piece to be square root of 7. Okay, so if I'm looking for the tangent of y, now the tangent of y is just going to be opposite over adjacent, so 3 over root 7. Okay, so that's my answer right there. Okay, let's try another one here. Okay, so cosine of arc tangent or inverse tangent of 1/2. Okay, I'm going to do the same thing. I'm going to let y be that inside stuff, so we're looking for the cosine of y. Okay, so if y equals arc tangent, then the tangent of y is that 1/2 stuff, so opposite over adjacent. So there's, I didn't put y, but there's y right there. Okay, so since we're dealing with cosine, I got to get the hypotenuse here, so that's going to be the square root of 5. Okay, so the cosine is adjacent over hypotenuse. Okay, easy enough. All right. All right, when you're dealing with negatives, you guys, on arc sines and arc cosines, you have some, do the same thing right there, you have some limitations. And so because these are inverse functions, you guys, or arc functions, then you have some restrictions. So for sine restrictions, sine is only dealing in quadrants 1 and 4. That's in another lesson why, just believe me, it is. Cosine is always dealing for this stuff in quadrants 1 or 2. So if it's negative, it would be in 2 for cosine. If it's negative for sine, then it's in quadrant 4. Okay, and tangents dealing with quadrants 1 and 4. Actually, I think it's 1 and 2. Oops, I think it is 1 and 2. Anyways, this one's arc sine right there. Okay, so since we're dealing with arc sine and it's negative, then I'm dealing in quadrant 4 because it's arc sine and that's a negative right there. So it's sine is negative in quadrant 4. So cosine is going to be positive. So this is going to be a positive answer right here. So go ahead and set up your right triangle, and then my sine is opposite over adjacent. So I disregarded the negative since cosine is positive right there, and then just get the cosine of that angle, and there's the angle right there. That's supposed to be angle y right there. So the cosine of that angle is going to be 2 root 2 over 3. Okay, and then so derivatives, find the derivative of each. Okay, so if f of x equals inverse sine, let y equal that. So then that means the sine of x equals this y right here. Okay, so then we implicit differentiate. So when I implicit differentiate that, that's 1, and then this is going to be cosine of y dy, or cosine of y prime. Okay, and then solve for y prime. And then I get secant of y, but the function is in terms of x, so we need to get our answer in terms of x. So what we're going to do is go ahead and set up my triangle again right here. So the sine of y is going to be right here. The sine of y is opposite over hypotenuse, so there's opposite over hypotenuse. So there's that third side right there using the Pythagorean theorem. Okay, so we're looking for y prime, so y prime is the secant of that, and since the cosine is adjacent over hypotenuse, then the secant is going to be hypotenuse over adjacent right there. Okay, all right, so same with this one right here. So we're going to go ahead and implicit differentiate right here, and when I implicit differentiate, remember the derivative of secant is secant tangent right there, so there that is right there. Okay, so y prime is 1 over secant tangent when I solve for y right here, so I divided both sides by secant tangent right there. Okay, and then we got to figure out, set up my right triangle again. So since the secant of y equals x right here, so the secant of y is hypotenuse over adjacent right there, so x over 1, so that's x squared minus 1. Okay, and this is just leading us into our arc, our integration of inverse trig right here. Okay, so anyway, so there's the cosine of y right there. Okay, so the cosine of y is adjacent over hypotenuse. And then the cotangent of y is cosine over, actually it's adjacent over opposite right there, so that's that right there, okay? So there it is, simplified right there. Okay, so basic derivative rules, that's how we found all of these right here. That's I could do that with all of them. Those are our basic derivative rules. That was in section 5.8, I think, in our textbook. And this is chapter 7 right here. So there's our basic derivative rules. So when I integrate these guys, it's going to get me back to these guys right there, okay? So integration involves the inverse trig function. So the integration of du over the square root of a squared minus u squared is arc sine of u over a plus c. And there's 1 over arc tangent of u over a plus c. Okay, so notice there's no square root on that. So that's a is just a constant, you guys. Okay, and then there's arc secant right there if it follows this pattern right here. So we're going to do examples of all of these coming up right here. Okay. So evaluate each integral. All right, so here's this one right here, okay? So this one is following this arctangent because there's no square root right there, okay? So so this is going to be, there's that 4 comes out, so it's going to be x squared plus 3 squared, okay? So the 3 is that a part right there. So just following that rule over there, so it's going to be 1 over a, which is 1/3, arctangent or inverse tangent of x over 3, then plus c right there, okay, and then so that's just going to be 4/3 right there, okay, arctangent of x over 3 plus c. Okay, let's try another one right here. Okay, so this one's 4x over x squared plus 9. That x kind of holds us up a little bit right there. So let's go ahead and do a u substitution. Okay, so if we let u be that, then you can see that that's going to get me that right there, which is the natural log. So there's my final answer right there. And I don't need the absolute values because x is being squared, so it's ensuring that it's positive right there. Okay, and then this guy right here, what I would do with this one is pull that 4 out, and then this is just a trick right here. And I didn't just think of this right off the bat, you guys. This is just from practicing and looking back at my notes and stuff. So this is plus 0 right there. And what this is going to do is it's a nice handy little trick right there. Here's this x squared plus 9 over x squared plus 9, and then minus 9 over x squared plus 9. And so this minus 9 with this 4 is that minus 36 right there. And then here's my arctangent right here. And then this is just 1 right there. Okay, so what that's going to do is get me my arctangent right there. This is 3 squared right there. So this is going to be 1/3 comes out right there. So it's 36/3 of x over 3, and then the integral of just 1 is just x, so it's 4x right there plus c. Don't forget your plus c, you guys, because this is indefinite right there. Okay, and then I just simplified that, 36 over 3. Okay, let's try another one here, you guys. Okay, oh, same for this one right here. So if you had x squared over x squared plus 1, I'd make it, I think this is one of your homework questions, you guys. I'd do plus 1 minus 1, and you get the same sort of setup on that answer right there. You guys see that? Okay. All right, so this guy right here. Okay, so the trick on this one here is see if you can do a u and a du, and you find out that you're going to run into a dead end. This kind of looks like it might be arc sine right here. Okay, but this x plus 3 is not just du right there, so I can't do a u and du. So if you split them up, you guys, you can do this right here. Then I can do a u substitution on this side right here. U is this stuff right here, and then this one's going to get me that arc sine right up there, okay? So there's that arc sine right there. And then let's see, so did I do something wrong? I sure did. I'm missing a 2 right there. There should be a, no, I'm good, I'm sorry. All right, so and then I did a u substitution over here. You guys with me? Sorry about that. And then when I did a u substitution over there, I get this side over here because it's this 2 times negative 1/2 is just negative 1, and then this is the square root of u, and u is at this right here, so the square root of 4 minus x squared. Okay, and I know it's going fast, but you can see what I'm doing right there. And then this side right here is my arc sine right there. Okay, So it's just showing you some tricks right here. Okay, on this one right here, this one is an arctangent right here. So can you see the arctangent coming out right here? So I'm going to do a u substitution with this. This is going to be my u right here, and then so when I take the derivative of x cubed, it's going to get me 3x squared, which is going to take out that x squared right there. And then there's my arctangent right there. Okay, so my arctangent is going to get me, I'm sorry, arcsine. What the square root is arcsine. And so that's going to get me u over 4, and then this is my 1 over 3 right there, okay? So there's my final answer right there. Substitute back your u back in, okay? Just some tricks I'm showing you on this, okay? Okay, this one here, you guys, this one kind of looks like it might be tangent, but it's not. You run into a jam. So here's another trick on this guy right here. And again, you guys, I didn't just think of this right off the bat. It's just from practicing and seeing other awesome teachers work on this, you guys. One of my master teachers was Mr. Hand over at Bella Vista High School, and then Mrs. Sargent was a great master teacher of mine that I got to follow, had the pleasure of following. Anyways, so this is just, I multiplied it by 1, and what that does is then I can use this as a u substitution for the denominator, and then my du is going to take out that top right there. Check this out, you guys. Okay, so if I let u be the denominator, then du is the numerator except with the negative right there, and then this is just natural log right there. Isn't that cool, you guys? Okay, so this one right here, you guys, again, just playing around right here. If I let u be that stuff right there, so then du is the inverse of that times the derivative of that, which is just your cotangent right there. So this is just going to end up being the integral of u, which is u squared over 2. Okay, and then so my u is, remember my u is this whole thing right there, and don't get that confused with this right here. This is not equal the natural log of the sine of x squared, because actually if it was this 2 would come out in front and would be 2 times that. So this is my answer, this is not my answer right there. Okay, and then for those of you guys that are trig identity challenged, like some of you guys are, I know some of you guys are, I used to be. Okay, so here's my trig identity with tangent. Tangent squared is secant squared minus 1. So if you go ahead and do secant squared minus 1 and then separate those up, you get that as your answer. All right, well that's it. And if you're in my calculus class, I would probably assign you that as your homework assignment. Take care, you guys.